Hello students, I hope you are all doing good. I welcome all of you for today's class. Students, we often come across statements like 1 year interest for FD, that is fixed deposit in the bank at 9% interest per annum, or savings account with 6% interest per annum. So, let's try to explore more about such things and try to understand them, which will be very much helpful to solve real life problems. Students, interest is the extra money paid by the institutions like banks, post offices on the money kept or deposited with them. It is also paid by the people when they borrow the money. In fact, we had also seen how to find the simple interest. So, to find simple interest, we have simple interest is equal to P T R divided by 100, where P is the principal, T is the time in years, R is the rate of interest per annum. Students, now let us try to solve a problem on simple interest. The problem goes like this. Kavya borrowed a sum of rupees 10,000 at a rate of 15% per annum for 2 years. Find the simple interest on this sum and the amount to be paid at the end of 2 years. Students, let us try to solve this problem by using the formula which we stated earlier. Before that, let us try to make a note of the given data. It is given that the principal, that is P, is equal to rupees 10,000, and then the rate of interest, that is R, is equal to 15% per annum. The time is given to be 2 years. We know that simple interest is equal to PTR divided by 100. So, the principal amount is 10,000 multiplied with the time is 2 years multiplied with the rate of interest is 15% divided by 100. So, upon simplification, we get the simple interest is equal to 3,000. Students, we found that the simple interest is rupees 3,000. We should also find the total amount should be paid by the Kavya after 2 years. So, the total amount will be the principal plus the simple interest. So, amount to be paid by Kavya at the end of 2 years will be principal plus interest, that is equal to rupees 10,000 plus rupees 3,000, that is equal to rupees 13,000. Students, note that one can also solve this problem without using the formula. So, let us try to solve in that way. Observe that on rupees 100, interest charged for 1 year is rupees 15. So, on rupees 10,000, interest charged for 1 year is 15 by 100 multiplied with 10,000, that is equal to rupees 1,500. Make a note that this is the interest on rupees 10,000 for 1 year, but then we wanted to calculate for 2 years. So, interest for 2 years is equal to rupees 1,500 multiplied with 2, that is equal to rupees 3,000. So, amount to be paid by Kavya at the end of 2 years is equal to principal plus interest, that is equal to rupees 10,000 plus rupees 3,000, that is rupees 13,000. Students, let us observe another situation. A boy named John said that his father had kept some money in bank for 3 years. So, every year the money increased more than the previous year. He observed in the passbook that some amount of interest is added to that every year, but this interest is not the same. So, he observed that the interest added is increasing every year. Students, normally the interest paid or charged is never simple. It is always calculated on the amount of immediate previous year. This we call it as interest compounded or simply compound interest. If the interest calculated on amount of previous year, then the interest is known as interest compounded or compound interest, simply denoted as CI.
Arnav borrowed rupees 50,000 at 15% per annum simple interest for 2 years and lent it to Keshav at the same rate the same day compounded annually for 2 years. He says by doing so he gets profit in it. This means that the compound interest is more than the simple interest. So let's try to solve some problem to understand more about this concept.
Students, let's see how to calculate the compound interest by taking up the following problem. The problem goes like this. A sum of rupees 20,000 is borrowed by Arun for 2 years at an interest of 8% compound annually. Find the compound interest and the amount that he should pay at the end of 2 years. Students, carefully make a note that the compound interest is always calculated on the amount of immediate previous year. So, let's try to find the compound interest on the amount to be paid in the following steps. In the step 1, find the simple interest for first year. So, let the principal for the first year be P1. So, in this case P1 is equal to rupees 20,000. So, SI1, that is simple interest at 8% per annum for first year. So, by using our formula, that is PTR by 100, we have 20,000 multiplied with 1 multiplied with 8 divided by 100, that is equal to rupees 1,600. In the step 2, find the amount to be paid at the end of first year. This becomes the principal for the next year. So, amount to be paid at the end of first year is equal to P1, that is the principal amount for the first year, plus SI1, that is simple interest per annum for first year, that is equal to rupees 20,000 plus rupees 1,600, which is equal to rupees 21,600. So, this will be our principal for the second year. So, let us denote it as P2. In the step 3, again find the interest on this sum for another year. So, SI2 is equal to simple interest at 8% per annum for second year. So, make a note, our principal now here is rupees 21,600 multiplied with, the time is again 1 year here, multiplied with the rate of interest remained the same, that is 8% divided by 100. So, that is equal to rupees 1,728. So, in the step 4, find the amount which has to be paid or received at the end of second year. So, here amount at the end of second year is equal to P2 plus SI2. So, here our principal for second year is rupees 21,600 plus the simple interest for second year is rupees 1,728. So, the sum is rupees 23,328. Students, Arun has to pay rupees 23,328 after 2 years. Students, we can observe that the total interest was rupees 1,600 for first year, rupees 1,728 for the second year. So, the total interest was rupees 3,328. But let us calculate the simple interest for these 2 years. So, simple interest for 2 years is equal to, the principal amount was 20,000 multiplied with the time is 2 years multiplied with the rate is 8% per annum. So, divided by 100, which is equal to rupees 3,200. Students, we find that the compound interest is rupees 128 more than the simple interest. So, if Arun would have used compound interest, he would pay rupees 128 more. Students, let's try to look at the difference between the simple interest and the compound interest. So, to have a clear distinction between these two, let us take up a principal of rupees 100 at the rate of 10% per annum. Look at the given table. So, in the first year, the principal amount under simple interest is rupees 100 and of course under compound interest is also rupees 100. Since interest is at 10%, under simple interest it is rupees 10 and under compound interest it is also rupees 10. So at the end of first year, under simple interest the amount will be rupees 110, which is the same under compound interest. For the second year, the principal amount will not change under simple interest, but under compound interest it is rupees 110, for which 10% will be rupees 11, and hence at the end of second year the amount under compound interest will be rupees 121 and under simple interest it will be rupees 120, that is rupees 10 added to rupees 110, it will be rupees 120. And in a similar way we can observe that for a third year, at the end of third year the amount under simple interest will be rupees 130 and under compound interest it will be rupees 133.10. Note that in 3 years rupees 130 minus rupees 100, that is equal to rupees 30 interest is earned by simple interest, and rupees 133.10 minus rupees 130, that is equal to rupees 33.10 interest is earned by compound interest. One should observe that every year principal remains the same under simple interest, while it changes year after year under compound interest. Students, it's obvious that whenever we wanted to find the compound interest for a large number of years, so finding in a stepwise for each year is bit tedious. So let's try to deduce a formula for finding the compound interest. Let P1 be the sum on which interest is compounded annually at a rate of R% per annum. Let SI1 be the simple interest for the first year and A1 be the amount at the end of first year. So by our formula, SI1 is equal to P1 multiplied with R multiplied with 1 divided by 100. So the amount at the end of the first year, that is A1, is equal to the principal amount, that is P1, plus the simple interest for the first year, that is SI1. So that is equal to P1 plus, so just now we have observed that SI1 is equal to P1R divided by 100. So by taking P1 common from these two terms, we get P1 times 1 plus R by 100. So this will be our principal for second year. So let us denote it as P2. So let us find the simple interest for the second year, that is SI2 is equal to P2 multiplied with R multiplied with 1 divided by 100. Just earlier we had seen that P2 is nothing but P1 times 1 plus R by 100 multiplied with R by 100. So we can write it as P1R divided by 100 times 1 plus R by 100. So the amount at the end of the second year, that is given by A2 is equal to P2 plus SI2. So we know that P2 is nothing but P1 times 1 plus R by 100 plus just now we found SI2 is nothing but P1 R by 100 times 1 plus R by 100. Now let us take the common term as P1 times 1 plus R by 100. So by taking this as common term, we have P1 times 1 plus R by 100 times, so by taking this as common in the first term we are left out with 1 plus in the second term we are left out with R by 100. So this is nothing but P1 times 1 plus R by 100 whole square. So this will be our principal amount for the third year. Let us denote it as P3. So proceeding in this way, the amount at the end of the nth year will be AN is equal to P1 times 1 plus R by 100 to the power of n, or we can say that A is equal to P times 1 plus R by 100 whole to the power of n, and thus we have our initial sum P and
the final sum A, by which we have compound interest is equal to A minus P, where A is the final amount and P is the initial sum, and thus we can easily find the compound interest.
Students, we can use this formula to find the compound interest in many real life problems. So, in fact, let us list some of the applications of this formula.
We can use this formula for calculation of compound interest in following real life problems, such as increase or decrease in population, the growth of bacteria if the rate of growth is known, and the value of an item if its price increases or decreases in the immediate years, and there are many such real life problems.
Students, firstly, let us try to solve a problem on population.
The problem goes like this. The population of a place increased to 54,000 in 2003 at a rate of 5% per annum. What would be its population in 2005?
Students, we observe that every year there is an increase of 5% population. So, every new year has a new population. So, this increment is in compounded form.
Firstly, let us make a note on given data. It is given that principal is 54,000, rate is given by 5% per annum, and the number of years n is given by 2 years. So, the population of the place in 2005 is, we know the formula, A is equal to P times 1 plus R by 100 whole to the power of n. So, that is equal to, so principal is 54,000 times 1 plus R is 5%. So, 5 by 100 whole to the power of n is 2. So, upon simplification we get 54,000 times solving 1 plus 5 by 100 we get 105 by 100 to the power of 2. So, that is equal to 54,000 multiplied with 105 square is nothing but 11,025 divided by 100 square is equal to 10,000. So, upon simplifying these two terms we get 59,535. Hence, the population of the place in 2005 is 59,535.
Students, note that time period need not be the complete whole year every time. Sometimes we may need to find the compound interest, say for example for 1 year 5 months at the rate of 12% per annum. So, let us try to address one such problem.
The problem goes like this. Aisha borrowed rupees 26,400 from a bank to buy a scooter at a rate of 15% per annum compounded yearly. What amount will she pay at the end of 2 years and 4 months to clear the loan?
Students, the idea behind solving this type of problem is to find the amount with compound interest for the whole part of year. Say for example, in this case it is 2 years 4 months. So, the whole part is 2 years. So, and then we use this amount as principal to find the simple interest for the rest of the 4 months. So, let us solve this problem.
That is, we find compound interest for 2 years and then use the obtained amount as principal to find the simple interest for the rest of 4 months, that is 4 by 12 years. It is given that the principal amount is rupees 26,400 and the rate of interest is 15% per annum compounded yearly. So, the number of years is, here we are taking the whole part. So, n is equal to 2. We know that A is equal to P times 1 plus R by 100 whole to the power of n. So, the amount after 2 years will be 26,400 times 1 plus 15 by 100 whole to the power of 2, that is equal to 26,400 times 115 by 100 whole to the power of 2, that is equal to 26,400 times 115 whole square is 13,225 divided by
100 square, that is 10,000. So, upon simplifying this, we get A is equal to 34,914. Hence, amount after 2 years is rupees 34,914. Students, now let's try to find the simple interest for the remaining 4 months, that is nothing but 1/3 years with the above amount as a principal. Make a note that your time period must always be in years. So, we have for next 4 months the principal is equal to rupees 34,914. This is what we had got, the amount after 2 years. And the time is 4 months, we have to convert it to years. 4 months is nothing but 1/3 years. So, rate is equal to 15% per annum. Therefore, simple interest is equal to, by the formula PTR by 100, where the principal is 34,914 times the time period is 1/3 year times the rate of interest is 15% divided by 100. So, that is equal to 34,914 times 1 times 5 divided by 100. We have cancelled the terms 3 1s and 3 5s. So, upon simplifying this, we have 34,914 divided by 20, that is equal to rupees 1,745.7. Hence, simple interest for the last 4 months is rupees 1,745.7. Therefore, the total amount to be repaid by Aisha to clear the loan is amount at the end of 2 years plus simple interest for the 4 months, that is equal to rupees 34,914 plus rupees 1,745.7, that is equal to rupees 36,659.7. Students, in the previous problem, it was mentioned that at the rate of 15% per annum compounded yearly. So, that means we can also have the rate of interest which are compounded half yearly or quarterly. So, the time period after which the interest is added each time to form a new principal is called conversion period. Students, when the interest is compounded half yearly, there are 2 conversion periods in a year, each after every 6 months. So, now let us find what happens when the interest is compounded half yearly. Suppose in a bank, if interest is compounded half yearly, that is semi-annually, let P be the principal amount, R be the rate of interest per annum, N be the number of years. Students, since the interest is compounded half yearly, for every 6 months, simple interest is calculated at the rate of R by 2, since R is per annum, and this simple interest is added to the principal amount, and this amount will be the principal for the next 6 months. So, we obtain the following formula to calculate the amount for the above data. So, A is equal to P times 1 plus R by 2 divided by 100 whole to the power of 2n. We have 2n because there are 2n half years in n years. Students, let us take up a problem to check how this formula works. The problem goes like this. Shyam invested rupees 60,000 at an interest rate of 12% per annum compounded half yearly. What amount would he get after 1 year? Students, before we solve, let us make a note of the given information. It is given that principal is rupees 60,000, R is equal to 12% per annum and N is equal to 1 year. Since the interest is compounded half yearly, The amount after 1 year is given by, we have the formula A is equal to P times 1 plus R by 2 by 100 whole to the power of 2n. Here we have P as 60,000 multiplied with 1 plus, given that R is 12, so 12 by 2 whole by 100 whole to the power of 2. That is equal to 60,000 times 1 plus 6 by 100 whole to the power of 2, that is equal to 60,000 times 106 by 100 whole to the power of 2, that is equal to 60,000 times 11,236 divided by 10,000. So, upon simplifying these terms, we get 67,416. Hence, the amount he gets after 1 year is rupees 67,416. Students, we end our class at this stage. Before we wind up, let's recollect what all things we have learned today. We started our class with simple interest. We solved problems on simple interest. Then we looked into the compound interest. We have also deduced a formula to find the compound interest. And we have also listed some of the applications of this formula. Finally, we solved problems on compound interest of two types. Firstly, interest compounded annually or yearly, and interest that is compounded semi-annually or half-yearly. So, this ends the chapter comparing quantities. Hope you have enjoyed the class. Have a good day. Thank you.